Okay, so welcome back. Um, we have our next question, which reads: cyclist traveling downhill accelerates uniformly at 1.5 meters per second squared. With his initial velocity at the top of the hill is 3 meters per second. That's this velocity, this acceleration. And so they are saying that we should find how far he travels in 8 seconds. So we are given three things: velocity, initial velocity, constant acceleration, and the time. We are asked to find the distance, how far. That's, you can see how far, that's the distance. So here we are going to use one of the equations of motion, the one that contains obviously distance. So we will use this one: v squared equals to u squared plus 2as, where s here is the distance. So making s the subject, s will be equals to v squared minus u squared all over 2a. But from the question, our a is equals to, that's our acceleration, one whole number, 1 over 2 meters per second squared. Our v is equals to, our u is equals to u is 3 meters per second, and then our time is equals to 8 seconds. Well, we don't have final velocity, so it will be difficult to use this particular formula here because we don't have v, we only have u. So what do we do? Well, there is another one equation, which is s equals to ut plus half at squared, like this. So we know of this formula too, which we can use too. So I think this one, we have initial velocity, we have acceleration, and we have time in the question. So because of that, we can actually employ and use this one. So that implies that we have s equal to u is this, so that is 3, our t is 8 times 8 plus half a, our a is 1.5 times our t squared, like this. So using your calculator, you have 3 times 8 plus 0.5 times 1.5 times 64 gets 72. So 72 meters. So this is the distance that the cyclist traveled in just 8 seconds. So he traveled 72 meters far. Now they are saying how far he traveled before reaching a velocity of 7 meters per second squared. You see the question? How far he travels before reaching a velocity of what? 7 meters per second. So it means this is a final velocity given to us. So it means that since a final velocity is given to us, then actually you can use the other one, s equals to v squared minus u squared all over 2a, this one, because a final velocity is given to us, and so it becomes simple. So substituting, we know that our initial velocity from the question is 1 whole number, 1 over 2 meters per second squared. Our final velocity is given here, 7 meters per second, and then our e in the question its initial velocity is actually 3, not this. It's 3 meters per second, So 3 meters per second, and then his acceleration is equal to the half meters per second squared. And so doing your substitutions, we have s to be equals to the final velocity 7 squared minus initial velocity 3 squared all over 2 times 1.5. So 49 minus 9 all over 3. You get 3. So using everything, putting everything in your calculator, so we get 40 over 3, which we can write as 13 whole number 1 over 3 meters. 1 over 1, yes, 1 over 3 meters. 13 whole number 1 over 3. 13 whole number 1 over 3 meters. So this is our s. Our s is equal to that, and that is all for this video. We break here, then we come back again to look at the next question. Thank you for watching. Kindly subscribe.